about 1.3 billion years ago.
As they orbit, the black holes are getting closer and closer to one another. The orbit is speeding up, and eventually they're going to merge. The event horizons are going to join, boom.
So I want to put this in perspective for you because I think it's very important, all right, to give a sense of what really happened here. So each of these black holes are about 150 kilometers in diameter, a little bit bigger than that. Take something that's 150 kilometers in diameter, so that's about a little bit bigger, maybe a lot bigger than the metropolitan Washington, D.C. area. Pack 30 times the mass of the sun in that. Accelerate it to about half the speed of light. Now take another thing, 30 times the mass of the sun. Accelerate at half the speed of light and collide them together. That's what we saw here. It's mind-boggling.
It was more than 1 billion light years away. This merger happened 1.3 billion years ago when multicellular life here on Earth was just beginning to spread. And the signal took 1 billion years to come to Earth and produce this tiny distortion in our detectors. We can hear gravitational waves. We can hear the universe. Now, I wanted to play the gravitational wave for you to hear, but it's so short that it's just a thump. So what we have done is taken the real signal and shifted a bit in frequency, but it's still the real signal. Did you hear the chirp? There's a rumbling noise, and then there's a chirp. Let me do that again. That's the chirp we've been looking for. This is the signal we have measured.
Wow. Einstein would be beaming, wouldn't he? This is obviously a very, very special moment. It's a very special moment for me personally to be able to hug a faculty mentor when I was a graduate student at Caltech, and hearing Kip and Virginia Trimble, the spouse of Joseph Weber, inspire students with stories of black holes, which seemed imaginary at the time. And look where we've come now. It's just amazing.